Welcome back, students. This is the session 1 from the playlist of Nucleus. The topic is the introduction to the nucleus, and based on this topic I have written here 7 important points which will help us to understand this topic in brief. So the first point is that nucleus is located at the center of the atom, and it is positively charged, and it consists of protons and neutrons. Now proton is a positively charged subatomic particle, and neutron is electrically neutral. The almost all the mass of the atom is concentrated in the nucleus, because the mass of the proton is equal to 1.672 into 10 to the power minus 27 kg. The mass of the neutron is equal to 1.674 into 10 to the power minus 27 kg, and the mass of the electron is equal to 9.1 into 10 to the power minus 31 kg. So from here we can see that the mass of the electron is very less in comparison to the mass of the proton and the neutron, and because of this reason we can say that the mass of the atom is almost concentrated in the nucleus. Here the mass of the proton is almost equal to the mass of the neutron, but actually the mass of the neutron is slightly more than the mass of the proton. So the third important point here is that the number of protons is equal to the number of electrons, which is equal to Z. And what is Z? Z is the atomic number of the nucleus. Now this is true when the atom is stable. In a stable atom, the number of electrons will be equal to the number of protons, and in a stable atom is electrically neutral. So in that case, the number of electrons will be equal to the number of protons, and the number of electrons or the number of protons is equal to Z, which is called the atomic number. The fourth point is the atomic mass number of a nucleus, which is depicted by capital A. This is equal to Z plus N, where Z is the atomic number and N is the neutron number, which is equal to the number of neutrons in the nucleus. The fifth point is that the radius of the nucleus is equal to is depicted by capital R, which is equal to R naught into A to the power 1 by 3, where A is what? It is the atomic mass number, and R naught is approximately equal to 1.3 Fermi, where 1 Fermi is equal to 10 to the power minus 15 meter. Here Fermi is denoted by Fm. So R naught is basically a constant, and its value is approximately equal to 1.3 Fermi, where 1 Fermi is equal to 10 to the power minus 15 meter. So the volume of the nucleus will be equal to, is given by V is equal to 4 by 3 pi. It will be equal to 4 by 3 pi R cube. Now I have simply substituted the value of R as R naught into A to the power 1 by 3 in this equation, that is 4 by 3 pi R cube, and by substituting the value of R in the equation of the volume, I will be getting the volume as 4 by 3 pi A R naught cube, because here 4 by 3 pi, this will be equal to R naught cube, and A to the power 1 by 3 into 3 will be equal to A. So finally the volume will be equal to 4 by 3 pi A R naught cube. Now the density will be equal to mass upon volume, and this is equal to 3 into mass of the proton divided by 4 pi R naught cube. See, this formula has been derived considering the fact that the mass of the proton is approximately equal to a mass of the neutron. Sorry, we have for calculating the density of the nucleus, we have considered that the mass of the proton is equal to the mass of the neutron. Actually the mass of the proton is slightly more than the mass of the proton. So if the mass of the proton is taken equal to the mass of the neutron, then the formula will be equal to 3 mp divided by 4 pi r naught cube. but actually the actual mass of the nucleus will be equal to Z. Z is what? It is the number of protons multiplied by the mass of the proton plus N, where N is the number of neutrons multiplied by the mass of the neutron. So this is the true mass of the nucleus. But if I consider the mass of the proton to be equal to the mass of the neutron, then I can write the density equal to 3 mp divided by 4 pi r naught cube. How we have got this value? We have we'll just write it here. If I consider the mass of the proton equal to the mass of the neutron, then the mass will be equal to the atomic mass number multiplied by the mass of the proton divided by the volume, and volume is equal to 4 by 3 pi a into r naught cube. So if I put this value in place of V, I will be getting the density as 3 into mp divided by 4 pi r naught cube. So thank you very much for joining this session. In the next session, I will be discussing about the isotopes, isobars and the isotones. So till then, have a nice day. Bye.